Hi, we're just still starting chapter 5, and our lesson today is an extension of yesterday's lesson. We talked about the basics of square roots, simplifying square roots. So today I'm giving you more detailed square roots, things that might not be a perfect square or a perfect cube, and then more variable simplifying. So you'll see as we get into 3 and 4, the variables will become a little harder. Okay, so recap. The index is the root, the small number. The number underneath is called the radicand. And a rational exponent means a fraction. So that m over n is called the rational exponent because it's a fraction. I did some things over here on the side, like the square root of f squared is just an f. The square root of 4x to the fourth, well, the square root of 4 is 2. The square root of x to the fourth is x squared. And then cube root of 27g to the sixth. Since it's a cube root, it would be like 3 to the third, g third, g third. And that's how everything came out. A 3 came out, no longer underneath. A g came out, and a g came out, which gives me the 3g squared. Okay, so now we're going to go through. I'm going to go slow and expand a lot of things just so everyone's clear on, and we're brushing up on our Algebra 1 skills. It's been a while. So 3 times. The 3 in the front means that I'm going to multiply, and it's going to stay in front, a whole number 3. The cube root of 108. Well, right now, off the top of my head, I don't know of a cube root that makes 108. But is there something else that is a factor of 108 that's a cube root? Yeah. 4 is not a cube root. That would be 44. Yeah. 27 times 4. 27 is the cube root. And again, I'm not expecting that you have that memorized. I know. Let's see. So the 3 stays on the outside. This cube root of 27 means that a 3 is coming out. So I said that this 27, cube root of 27 became a 3. But there is still a 4 underneath that I cannot change. The answer is 9 times the cube root of 4. All right. 162. So let's pretend I don't want anybody to give me an answer. What I'm going to do is I'm going to go like Algebra 1 method. When you don't know any factors or anything, you would divide by 2. So I'm going to sit over here and I'm going to break up 162 because there's nothing that's common with 162. So this is like a factor tree, like full-on elementary school, junior high factor tree, right? 2 times 81. So you're just like breaking it down. I need something that goes in that's multiplied 4 times. So I don't know so 81 could be like 9 times 9. And then, so I want something that's multiplied 4 times. I'm going to get it right here. 9 can be broken up. 3 times 3 is one of the 9s, and another 3 times 3 is another pair of 9s. Now, I have this 4 times. That means that I can pull this out as a 4th root because it's the same number multiplied 4 times. The 81 is a 4th root. It's 3. So I'll go back underneath. The 4th root of 2 times, and I can write 81 here, or I can write 3 to the 4th. I think you probably might like it if I write 3 to the 4th. I can take out this 3, and it's just a single 3 now. 4th root of 2. And that's my final answer. The cube root of 54, h cubed. 54. I need to think of a cube root. Do you need to see what the cube roots are? 2 to the 3rd is 8. 3 to the 3rd is 27. 4 to the 3rd, 4 times 4 is 16, times another 4 is 64. Obviously, 54 is not going to be the 64. Does 27 go into 54? Could I use that? It does. The cube root of 27 times 2, h cubed. The 27 is the cube root. 27 comes out. What does it come out as? 3. What else can come out? H cubed. I've simplified the most I could. I now write the leftovers, if you want to call them those. Whatever's still remaining. It's just a 2 underneath. All right, do number 4 on your own. Watch out for that k to the 4th. Do number 4. All right, cube root of 32. What'd you guys do? 8 and 4. So 8 times 4. And what'd you do with the k to the 4th? K cubed k. That makes 4. Take out what you can, which is going to be the 8. Comes out as a 2. K cubed comes out as just a k. All right. 3, 3rd root of 4, and then a single, this k is still under. Right? All right, so the rest are just, like this one is just variables. It's a 4th root. I need to make that 20 into 4s. x4, x4, that's 8. x4, that's 12. x4, that's 16. Here's 20. And then y to the 8th. Change it to y4th, y4th. All right, take out anything that's a 4, which is gonna be everything. 1, 2, 3, 4, 5. X to the 5th. Y squared. Are we all clear on that? I want to make sure your Algebra 1 skills are back up to date. Number 6 isn't hard at all. Work on it. I'll give you the answer in like 45 seconds. Go ahead and do number 6. Yeah.
For this one, wasn't still in the root.
It's not in the root anymore because everything canceled out. Like the 4th root of x to the 4th came out as just an x. No more root. Right? 4th root of x to the 4th. The 4s do opposite jobs canceling.
Yeah.
Yeah.
I tried out before we did that, and I tried like dividing the exponent by.
That works too. Yeah. Yeah. All right, here we go. Did you get 7y cubed times z? It was a square root. All right, 7 and 8. Isolate. Let me write that on the side. Isolate the variable. There's going to be some division that needs to occur, and then I'm going to root both sides. So first on number 7, what? On number 7, I'm going to divide by 2. X to the 5th equals 64 cut in half, right? And then you 5th root both sides. So I'll do that in a different color, and I'll write it like this. 5th root in order to cancel out the exponent of 5. There is a number when you multiply it 5 times by itself, it's 32. What is it? 2. All right. Number 8. I'm going to divide by 2 first. P to the 4th equals 162 cut in half. 81, yeah? How am I going to get rid of the power of 4? New volunteers always. I don't want to hear from the same people over and over. You've already helped me. You've already helped me. Yeah. 4th root both sides. Now, this is a 4th root. It's a plus or minus 3. Because I could go -3 times -3 times -3 times -3 and get a positive 81. All right. Last few on the back. Number 9. By yourself, go. Talk to your group too. I always am happy when you guys are discussing and sharing and working together.
It's 200.
You're gonna find out. You're gonna find out what the last digit is, and then you can. I didn't get.
All right. You eventually ended up with it. You eventually ended up with this. What'd you say the answer was? You guys can't answer every question, especially because you're right up front. Okay? Gotta let other people. All right. Next. So, we're going to, what I want to do on this is I want to root both sides. I think it's easier. So I am going to, since this is to the third root, I'm sorry, this is to the power of 3, I'm going to cube root both sides. BS means both sides. So I'm cube rooting both sides, which is going to mean that the parentheses is the only thing on the left. And I really don't even need the parentheses anymore. X plus 2. Now I have to be careful with this 729. Something times something times something does equal 729. This would be a time that you could play around on a calculator. Any ideas? 81 times 9. Okay, so this is a little factor tree, right? But 81 is 9 times 9. So here is this 3 times in a row, 9s. The cube root of 729 is 9. Is it a positive 9, a negative 9, plus or minus? What is it? Because this matters. The third root, it's a positive 9. It cannot be negative. And honestly, guys, then you're just subtracting 2 from both sides. X equals 7. $11. Oh. Go ahead. Do it on your own. I think you can. I have confidence and I believe in you because you're awesome.
Three.
Is it 3 times 3? It is 3. But then it's a 4 it's a plus or minus.
Yeah, it's equal to, so this is equal to 7. X is equal to
Plus, it's equal to plus 7 or
X is equal to 7.
no, negative
All right.
3 minus
Negative 1 minus 4 is equal to
plus 4.
Okay.
Oh yeah, 1.
So, for sure, the only first step is to 4 through both sides. Now, tell me what next. What'd you get when you 4 through to both sides? Yeah. X minus 4 equals 3. So you're saying the only way for me to get a positive 81 would be this 3 times 3 times 3 times 3. Is there any other option? Negative 3. So I'm going to go positive 3, and I'm going to do another equation with the negative 3 next to it. Plus or minus 3. Does anybody do this? This is like easy to miss. So, and then you're just solving for x. One of my answers is going to be 7. One of my answers will be 1. Both of those numbers plug in successfully into the parentheses. So on number 12 and 13, I'm going to isolate the variables. So first job, subtract 7 both sides, then divide by 2, and then I'll have the parentheses isolated. Then I cube root both sides. So, slowly but surely. First job is to subtract 7 both sides. And then, okay, one thing at a time, right? $61 minus 7 is 54. Then divide by 2. cube root. So the cube root cancels out the power of 3. X plus 3 equals 3. It's just a positive 3. Look at the root. It's a cube root. Something multiplied 3 times. I could not do a negative. I can't do negative 3 times negative. No, that wouldn't be it. Anyways, I subtract 3 both sides to isolate my... Now I have a 0 as an answer. 0 is a value. It's not worth anything, but it is an answer that's fine to get. Doesn't happen very often, granted, but... Okay. So on 13, the first thing I'm going to do is what? Subtract 3. Then multiply by 3 over 1, because that's the reciprocal of 1/3. And then square root both sides. So go to it. First I subtracted 3, and I got 1/3 times the quantity, x plus 5 squared equals 147. Then I multiply by 3 over 1. That cancels out the 1/3. One 147 times 3, in case you wanted to know, 441. Then square root both sides. Okay. This is going to be a plus or minus 21 times 21 is 441. X plus 5 equals positive 21. X plus 5 equals negative 21. X is 16. Also, it could be negative 26. All right, I'm going to stop the recording.